Very good morning, dear students. So today's concept is morphological image processing. The word morphology commonly denotes a branch of biology. It deals with the form and structure of animals and plants. The same word in the context of mathematical morphology is a tool. The mathematical morphology as a tool for extracting image components that are useful in the representation and description of the region shape. The region shape means, for example, will be called as boundaries, skeletons, and the convex, and also the morphological techniques used for pre or post processing. In the previous classes, we explain about what you mean by pre-processing. So here, this morphological process, pre or post-processing, such as the morphological filtering, thinning, and pruning. So in these sections, in the morphological sections, we have to use some concept. Some of the concept we are going to use set theory concept. This is for the powerful approach to numerous image processing problems, number of image processing problems we can use for that. So here in the morphological, in binary images, suppose we can have only two colors, either white or dark. The set of elements are number of two-dimensional integer space. There each element, two-dimensional means the coordinate will be called as x and y. We are using that x and y coordinates in the binary image. Before going to explain in details about that morphological image, some basic concepts. I hope that you are very familiar all these concepts. Subset, union, intersection. These are all things studied in your school programming or in the school days. So here some of the concept we are going to use, and along with some logical operations. I think we know some many more logical operations and are not. We can use to mask, or you can use corresponding pixels. We have many more gates are available, XOR gate, AND gate, all these things we are going to use. See here some examples. NOT gate, the first one. Here please look into that NOT gate. Here it become inverse, means that white will become dark and black will become white. And similarly here A and B components. If you are using AND operations, here If it is in the R operations, please look into this. And XR operations here. And the last one is NAND operations. So in these morphological, mainly you have two things. One is called dilations and second one it is called as erosions. These are the two operations are available in the morphologicals. These operations are fundamentals to morphological process. In fact, many of the morphological algorithms discussed in the chapters in this module, based on these basic concept, two primitive operations we are going to use. That is what we call as a dilations, and second one it is called as erosions. So what for these dilations and erosions? The dilations we are going to use expanding an element A. That is what we called as a structure element. By using the structure element B, you can expand the element A by using the structuring element B. The equations of dilations A by B and is defined in the following equations. Please look into that equations. These are the equation is very important, the examination point of view. Please look into these equations. This equation is based on obtaining the reflection of B. So here, this equation indicates that reflection B about the origin and shifting this reflection by Z. The dilation of A by B then is a set of all displacements. Displacement means you have to represent in the equation Z, such that is structuring element B overlap, A is overlapped by at least one element. So based on that interpretations, we can write that another equations, that is what 9.2.2 in the slide what we mentioned it. So here, please look into these example. First we'll take an asset A and then the structuring element B, can considering the structuring element B, the size of that D by 4, the structuring element. Keep on moving on the element, the dilation of A by B, the shaded lines, after the shaded line, it will be expanded. The dilation will become expanded. The expanded, it will be depends on the structure of the element, how much the size of the structure element. So, the similar way, one more example. Please look into the another example. You compare to the previous one. Please look into these examples. Here, the structuring element, one side, the length will become D, width will become D by 4. Keep on moving that. The dilation of A will become expanding. At how much? The expanding, it will be depends on the structure element. So the last one is elongated structures element. Dilation of A using the element, such element. The dotted borders in the last image, the boundaries is that boundary of set A. So one of the simplest applications of dilations is for bridging the gap. Here, same image with broken characters that we studied in the above mentioned equations. Some more interesting examples, we look into that. Some text we are going to consider. We have two text boxes. Poor resolutions, but it is marked that here YEAR. We can consider only E is a poor resolution with broken characters. By using the structure element 3x3 structure element, the bottom, this is what the structure element, this is structure element, this is what we are going to consider. This is considered as A, this is considered as a B. The dilation of A will become like this, dilation of A by B. The broken joints, so here the broken joints are here joint. So this dilation concept we can use wherever we require. Wherever we require, based on the applications we are going to use. Now next we will come to the second one, erosion. So the erosion is another concept. The erosion is used for shrinking the element A by using element B. Erosion for set A and B with similar equations, you have to consider all points from the Z. We can write that equations. So here similarly I can take an example of an erosion. The structure element we will consider D by 4. First we can take set E and the structure element will become square D by 4. Then erosion of A by B here. We look into that. The similar example. Similar examples what we considered in the dilation also. Set E, elongated structure element B we can use. Erosion of A using this element. Here, the third one. So duality between dilation and erosions. Erosion and dilations are a dual of such other with respect to set of complementations and reflections that would be represented in the equations. So one of the major advantage by using erosion is for eliminating irrelevant details. Any irrelevant details are there in that image, we can remove for that. So erosion and dilation summary here. In the first image will be called as different sizes of structure element may be considered 1, 3, 5, 7, 9. The B is the erosion, D of A, and C is the dilation of B. So dilation means expanding, erosion will be minimizing it. So this is what the good example you have to comparing with erosion and dilations. So here some more opening and closing operations we are going to discuss in the next class. So today's I will going to wind up only these concepts, basic concepts. So we'll come to the end of this class, erosion. What you mean by erosion? What you mean by dilation? First of all, we should know the definition of what you mean by morphological operations. In the morphological image processing, basic concepts, union, intersections, set, theory, you should know a little bit. This concept already you are studied during your school days. The same concept we can implement with respect to the particular image. That image you can use for different applications. Based on the application, either we can use either erosion or it may be dilation. Okay, I will continue in the next class. Thank you. Yeah.